have circled in red, okay, this one. So first begin with this point, okay. This point is called eutectoid point, okay, or eutectoid. The name is given like that, eutectoid point. So what is eutectoid point? What we can see at this point, if you see this gamma iron, if you cool the gamma iron, you will get some alpha or Fe3C. You can see such things you can find. So what will happen? Basically, what will happen? Gamma on cooling, okay? Gamma on cooling, you will get alpha plus Fe3C, okay? But this is also a reverse reaction. If you are having this part and if you heat it, you will get gamma iron. You can see on heating you will get gamma iron. So what will be the criteria? Means what will be the conditions for that? You can see at 0.8% carbon, at 0.8% carbon and 727 degrees Celsius. 0.8% carbon and 727 degrees Celsius, you will get this point, this eutectoid point. This is called eutectoid reaction, okay? And this point is invariant point. Invariant point means degree of freedom is 0. Let me see what is degree of freedom, okay? So what is degree of freedom? Suppose you are having a reaction at this point, okay? You will get this point only at 727 degrees Celsius and 0.8% carbon. If you change any of these 2 points, means this temperature or concentration, this point will disappear. So that means there are only 2 variables, composition and temperature. Remember, pressure is kept constant. Pressure is taken at 1 atm only. Pressure is kept constant, okay? We are not changing the pressure. So we know how we got F is equals to 0. Let me prove. We know P plus F is equals to C plus 1 according to Gibbs free rule, okay? So you can see at this point you will be having 3 phases, okay? Phases. Alpha, gamma and Fe3C. So P will be 3, okay? Then if we want to calculate what is C? C is the number of components. We have 2 components in this system. One is iron and another one is carbon. So 2 components. So F is equals to 0. We have proved that F is equals to 0 at eutectoid point. Why this is called Gibbs free rule, okay? Gibbs free rule. So why have you used 1 here? Because the pressure is kept constant. So instead of using C plus 2, I have to use C plus 1. It is called modified Gibbs free rule actually. Anything you can say. Modified. Modified Gibbs free rule, okay. Modified Gibbs free rule. So F is 0 at this point. Means this is called invariant point. So this is all about the eutectoid point. The second point is eutectic point, okay? Eutectic. Here also F is 0. Degree of freedom will be 0. So what is this point? You can see this point is called actually eutectic point. So what will happen if you start cooling it? This liquid will change into what? Gamma and Fe3C you can see. So gamma plus Fe3C. This is austenite ion. And again, if you want to get liquid, you have to heat it. If you heat this gamma plus Fe3C, you will get you will come in liquid region. So on heating also, this reaction can be achieved. But this reaction is achieved only at certain point. That is at 4.33% carbon, 4.33% carbon, and 148 degrees Celsius. At this point you will get eutectic point, and this is also invariant reaction. What is invariant point? Invariant point means degree of freedom is 0. Let me prove it. So P plus F is equals to C plus 1 according to modified Gibbs free rule. You can see three phases are there. One is liquid phase, one is gamma phase, and the third one is Fe3C, symmetric. So 3, if we want to calculate, there are two components, iron and carbon. So again, F is 0. So that means you can achieve eutectic point only at this condition. This is very important. In iron carbon diagram, if you reach this point, then only you can get this eutectic reaction. Okay. So this is all about the eutectic point. The third one is peritectic point. Okay. Peritectic. So what is peritectic point? Peritectic point, you can see I have circled this one also, this one. At this point, the peritectic reaction will occur, and this point is called peritectic point. So what will happen? You can see we have liquid plus delta iron, and if you cool it, you will get gamma. So liquid plus delta on cooling, okay? On cooling. Liquid plus delta on cooling, we will get gamma ion. But if we have gamma ion and if we start heating it, then we will reach this region, gamma plus delta. So this reaction is in equilibrium. Okay? And one more thing I want to say, all the things what we can see in this iron carbon diagram, they are all, this is a equilibrium diagram. Equilibrium diagram, remember this is an equilibrium diagram because all the reactions that are carried out, that is done very slowly. So since it is done very slowly, this iron carbon diagram is also called equilibrium iron carbon diagram. So remember this is very important. So, but we will again get this point, this eutectic point at certain condition. What is that condition? If we have 0.18% carbon, 0.18% carbon, and if we are having a temperature, if we attain a temperature of 1495 degrees Celsius, this point, 0.18% carbon and 1495 degrees Celsius, if we are able to attain this condition, then we will get peritectic point. Again, the degree of freedom is 0. How? Let's see. again you can see there are three phases: liquid phase, delta phase and gamma phase. So number of phases will be 3. P plus F is equals to C plus 1. So F is equals to C. There are two components, iron and carbon. So P plus F is equals to C plus 1. From here you will get F as 0. So this is also invariant point. Suppose if you have changed any of this condition, then you will not get peritectic point. You will reach to some other point. You will never get peritectic point. So this is also a very important point. See, degree of freedom is 0. Now there is one more point, important, but let me discuss it because you can see that point. Monotectic. Which is monotectic point? This point only. This point. This point is monotectic point, okay? So what will happen? You can see the liquid phase. You have liquid here, completely liquid. And if you start cooling it, you will get, on cooling, you will get gamma plus liquid. You can see gamma plus liquid, this region. But again on heating, if you are heating it, and if you have gamma plus liquid on heating, you will reach this liquid, you will get liquid phase, okay? So this is also an equilibrium reaction. But this is not a, what we can say, this is not a invariant point. Let me prove it. P plus F is equals to C plus 1, we know. If you see liquid, there is two phases, liquid phase and gamma phase. Two phases are there. So P is equals to 2. If we want to calculate, C again 2. C will be 2 because we have two components, iron and carbon. So F is equals to 1. This means the degree of freedom is not 0. Means what does it mean? It means that there is one variable, like if you are changing one variable also, you will be still having this point, monotectic point. That's why degree of freedom is 1. Degree of freedom is 1 because, I am again saying that degree of freedom is 1 because if you are changing any of the variable, any one of the variable, still you will be having monotectic point. It will not disappear. So that's why degree of freedom is 1. This is not an invariant reaction, okay? Well, degree of freedom is not 0. What we have seen earlier, the 3 points, eutectic point, and peritectic points. Those 3 points are invariant points. So these are the different points that are that need to be discussed. Okay, and one more thing I forgot to tell you, that this is liquidus line, the line above which he will find completely liquid. Okay, liquid region. That is, those lines are called liquidus line. This complete region, complete line, this complete line. What I have done, this complete line. This complete line is called liquidus line. Okay. What is solidus line? Solidus line means below that you will get completely solid phase. Okay. So let me see what is there. So if you draw this line, okay, this is below, this is solid, this is solidus line. Okay. Then below this is completely solid. So this is also solidus line. Okay, this is also solidus line, and this is also solidus line. So this you can see, this is called solidus line.